Have you ever wondered how the wiring is configured in your condenser outside for your air conditioning system? Generally speaking, perhaps leaning more towards a split unit, but anyway, on your condenser outside. So, starting from the basics, this is a contactor. We outside there are two motors. One has a condenser fan motor. One has a compressor that helps operate the system, moves the refrigerant, condenser fan motor pulls air, etc. These generally speaking, for a household, need 240 volts, somewhere thereabouts. So we have L1, L2, 120, 120. Okay, we have a low voltage that would pull in the contactor. If one put their meter here, they would read nothing unless this contactor was pulled in. Once it's pulled in, we have 120, 120. So we have the 240 now. So the 240 is able to actually energize the motor if everything's working properly. So just a quick layout. We have three windings in each. We have a start, a common, and a run. Again, just mnemonics. Remember the old shifter on the old car. They would call it, some would call it three on the tree. So just remember three, or stick three fingers up and remember three. Start, common, run. Okay, say this is the fan motor here. We run the start from here to the capacitor. Boom, over here. This is the fan side. This is the start that runs from here. Generally speaking, a black wire. It's not always, and it could be configured according to whoever's uh, tweaked the thing. So anyway, compressor. We run the start. We follow this wire. Boom, boom, boom. We go over here to the dual run capacitor. Emphasize run, underscore run, quotation marks run. Dual meaning two. Fan, Herm. This goes from the compressor to the Herm off of the start winding. Okay, so this is here. This other one, fan, Herm. So fan, compressor, common. Common has, generally speaking, has four prongs. So now we have the contactor. L1, L2, T1, T2, and just for mnemonics, we will call this C and R. C and R, common and run. Remember, we have to get 240 or 220, 240, somewhere in there to operate these motors, these two motors. So we've got to pick up one leg of voltage here, 120 here, the other half here. So what we do is and we'll just call this C and R, common. So what we do is we take the common from here, we follow it down 120 volts to one leg this side. We go down to the compressor, we find the C, we follow it, we go from C. Then we go up to the condenser fan motor, R, which is the run terminal. We follow this wire and we'll go here. We go to the compressor, we go to the run, and follow the run over here. So now we have C and run. So now we have 120 volts here, 120 volts here makes 240. Add the two together. So question is now, we have a dual run capacitor and we have a common. So what we do is take on this, remember, just for memory purposes, we called C and R. So this was the common side, this was the run side. The common side off of both motors, run side off both motors. We take a jumper wire here and go from here straight to the common. So now we have a common point on the run terminal. So again, a common point on the run terminal. So at this point, now if everything's working properly, if the low voltage pulls the contactor in, if everything's working properly, both motors should engage, the compressor and then the fan motor. So it's this is a quick chicken scratch schematic I laid out. I hope it helps. I hope it makes a little bit of sense. It may or may not. But anyway, again, this is the contactor. This is the fan motor. this is this. Remember, each motor, 3 windings, common, start, run. Common, start, run. Okay, we run to the common here, and we'll call the top part L1, L2, line voltage 1, line voltage 2, T1 here, T2, we'll just call this C and R, just for memory purpose. C and R, I have these labeled common and run. So we pull the common from one motor here, common from the other motor here. We pulled the run from here to here. So now we have this. Now we have one wire on the run side because we need a common. And this is where it can get a little confusing. So do keep your thinking cap on at this point, because we need a common for the run. So do not confuse that with these other commons. So forget that, forget all that information. We have both run terminals from 1-2 motor coming here. We need a common point. So we run a jumper wire from here to the capacitor, which is this. Remember, as covered in an earlier video, this is a dual run capacitor. Dual meaning two. Two, where are the numbers 2 at? 1, 2. Fan, compressor. Run, meaning it's a run capacitor. So remember, we call this, just for memory, C and R. And do not get this C confused with this common here off of the run terminal. So this is the R terminal here. We run, remember, we take this, we've already got the run coming here from this motor, the run coming here from this motor. So we're picking up 120 volts. We're picking up 120 volts on the other. And we take a jumper wire on the back side of one of these prongs, and we run it straight to the capacitor, which is the common point on the capacitor, which normally speaking has 4 prongs. The fan has either 1 or 2, and the Herm or the compressor or the hermetic has 3. So this is a panoramic view and a chicken scratch schematic that will hopefully give you a broader view of how it's working. So again, now we're working with low voltage and high voltage, because when we go to the contactor, we have the low voltage here. And simply all the low voltage does, it comes and it pulls that in. Once that's pulled in, this voltage here is like water on a dam. It's blocked up here. Nothing's happening right now. Once this is energized, once this is pulled in, this voltage jumps from here. And if everything is working properly and wired up properly, your system, and charged according to the proper specifications, your system may work well. Thank you for watching, and have a wonderful day.